In example 5C, our exponential equation is 7 times 9 raised to the negative x power is equal to 2. Okay, it's got an equal sign. The x is in the power that makes this exponential. Okay, when you look at this, okay, ask yourself, what is being raised to the negative x power? Well, only the 9. Okay, the 7 is just hanging out front. This is 7 times 9 to the negative x power is equal to 2. Okay, so with these exponential equations, before you can compare the base on the left to the base on the right, you really need to isolate the exponential piece. Okay, so I want to isolate this 9 to the negative x power. Okay, so I'm going to do that. Since I'm multiplying by 7, I'm going to divide both sides by 7. Okay, that way on the left, the 7's cancel since there's one in the top and one in the bottom. That leaves me with 9 to the negative x is equal to 2/7. Okay, when you look at 2/7 on your calculator, okay, that's an ugly decimal. Just leave it as 2/7. Okay, all right, now the exponential piece is isolated. Okay, the base is 9 on the left. The base on the right is 2/7 because that's what's being raised to the first power. There's no way I can make the bases the same. Okay, so when you have an exponential equation and you cannot make the bases the same, you need to involve logarithms. Okay, so once you can only take the logarithm once the exponential piece is isolated, and it is. Okay, so like what I'm saying is I want to emphasize this. If I had started this problem by taking the logarithm up here, okay, it's not going to come out right because the 7 is in the way. Okay, the exponential piece has to be isolated before you can take the logarithm. Okay, please remember that. Okay, all right, so this is where we leave off. 9 to the negative x is equal to 2/7, and I need to go ahead and take the logarithm of both sides. Let's see, I used natural log last time, so I'll go ahead and use log this time. Okay, again, it doesn't matter which one you use as long as you're consistent throughout the problem. So we're going to get the log of 9 to the negative x is equal to the log of 2/7. Okay, on the left side, we have the logarithm of something to a power, so the entire power is going to come down. Okay, so we're going to get negative x times the log of 9 is equal to the log of 2/7. Okay, log of 9 is a crazy decimal, log of 2/7 is a crazy decimal, so we're solving for x on the left. Okay, so what we can do, x is being multiplied by this crazy decimal log of 9, we can divide it off. Okay, whatever you do to one side, you have to do to the other. Okay, so on the left, log of 9, those two guys cancel, leaving you with negative x is equal to the log of 2/7 over the log of 9. Okay, we are almost there. We solve for negative x, and we want x. Okay, so we're going to have to get rid of the -1 that's in front here. So either multiply or divide both sides by -1. Okay, I'm just going to go ahead and, multiply by -1 here. Whatever you do to one side, you have to do to the other. Okay, so negative times negative will turn positive. Okay, we talked about this a long time ago. If you are multiplying a fraction by -1, you need to just multiply the top or the bottom by -1, not both. So let's see here. This is going to tell us that x, negative times negative is positive. So x equals, when you're multiplying the right side by -1, think of it as -1 over 1. Okay, so you're multiplying by a fraction. You're going to multiply across the top and across the bottom. So it's going to be negative. The negative sign can just go out front. Negative log of 2/7. Okay, you only send the negative to the top or the bottom, but not both. So since I sent it to the top, the bottom is going to stay the same. Okay, so x is going to, the exact answer is negative log of 2/7 divided by the log of 9. Okay, so let me box this. This is your exact answer. And then we'll go and grab the decimal approximation from the calculator. Okay, so let's go to the calculator, type it in exactly like you see it. Okay, this is going to be the negative log of 2/7 divided by the log of 9. Okay, so here's your answer. Okay, we're rounding to 3 decimal places, so 0.570 is our approximation. Okay, x is approximately 0.570. Okay, making sure I wrote that down right. Yes. Okay. All right, let's move on to part D. Okay, our equation is 3 times e to the 2x plus 1 is equal to 15. Okay, it's exponential. We've got an equal sign. It makes sense to solve for x. X is located in the power. We need to isolate the exponential piece. Okay, what is being raised to the 2x plus 1 power here? The e is. Okay, so this is really 3 times e to the 2x plus 1. 3 is not being raised to the 2x plus 1 power. Keep that in mind. Okay, so leave e as e. Please do not make it 2.71. Okay, so our first step here is isolating these guys, isolating the thing that's being raised to the power. Okay, so since this piece, the e to the 2x plus 1, is being multiplied by 3, we're going to get rid of the 3 by dividing off the 3. Okay, so they cancel and leave you with e raised to the 2x plus 1, okay, is equal to 5, because 15 divided by 3 is 5. All right, now we've got the exponential piece isolated. We can take the log of both sides. Okay, the thing is, even though you can use either natural log or log here, there's one that's preferred. Okay, we have e involved, and we know that e and ln are opposites, and they're going to make each other cancel. Okay, so you should use ln here. Okay, if you have a base e, you need to use ln. If you have a base of 10, you need to use log. Okay, it's not incorrect if you don't, but it makes your life easier. Okay, so in the next step, I'm going to take the natural log of both sides. The natural log of e to the 2x plus 1 is equal to the natural log of 5. If I take the logarithm of one side, I've got to do it for the other side. Okay, all right, what happens? Well, we learned a property in one of the prior sections that if e and natural log are side by side, and they are, there's nothing in between them, they're going to cancel, and the entire exponent is going to come down. So we're going to get that 2x plus 1 is equal to the natural log of 5. Okay, natural log of 5 is a crazy number. Leave it alone. Okay, so now we just need to solve for x. Okay, so we're going to isolate it. We're going to move the 1 over. Okay, so 2x is going to be equal to the natural log of 5. And I'm going to put parentheses on here just to make it clear I'm only taking the natural log of 5. We're going to subtract 1 from that quantity and then divide both sides by 2. Okay, so x as an exact answer is going to be the natural log of 5, that quantity minus 1 divided by 2. Okay, there's your exact answer. Crazy as usual. And now let's get a decimal approximation. Okay, so I'm going to type it in pretty much like I see it. Okay, so I'm going to go and do the natural log of 5, close parentheses, minus 1. This is the numerator. I'm going to take that and divide. So hit the division key, divide that by 2. Okay, so this is approximately 0.305. Okay, so we have our exact answer and we have our decimal approximation.